Hello again to another video in our multiplayer course. First let me organize and comment on some code here. This is vehicle controls. You comment on the nodes by selecting the node like this, select it and press C. You will have this comment. Let me delete this one, I do not need it. Let me go back, Control Z. Let me redo. And press on this show bubble when zoom so that you can read it from far away. Also here on begin play, let me comment on this one. Setup, input, mapping, and begin play. And here let's comment this, we call it track animations. Okay, now we need to implement the turret turning. So let's start. Now let's start by make the turret rotation and the gun pitch. To do this, we need to do some changes here. First of all, we do not need the controller yaw. We will change how is spring arm is rotated. Let me just make some room here. Now let's start by the turret yaw. First of all, we go to the spring arm and disable the pawn control rotation. We enabled it before because we wanted to test the input, and there is a way by taking the difference between the control rotation and the actual rotation of the tank, but that way will give us a jerky move. The tank rotation and the turret rotation will not be smooth, because if it is a single player it will be smooth, but in multiplayer it is considered like it will send big numbers, and these big numbers will not be updated very well, and this will cause the jerky movement of the turret. Now let's start. Let's get the spring arm. The turret yaw is easier than the gun pitch, because the gun pitch we need to clamp the inputs. Now for the spring arm, let's set relative rotation. Here, let's expand this one. We connect these. Now we connect the action value to the yaw. Now we will start with our first replication of let me delete this, I do not need them. First replication. First let's make a new graph. Let me call it replication graph. Here I will put all the replication logic to make things cleaner. Here let's start by adding a custom event. This custom event, let's call it the server set yaw, set turret yaw. we need this one to be run on the server, and we need it to be reliable. For me, and it is better to be reliable because the direction of the turret will also it will be useful, or will affect the spawn of the projectile. It will depend on the rotation of the O and the gun socket, so it's better to be reliable to give accurate calculations. Now here let's add an input. Let's call it Yo input. Let's promote this to a variable, and let's call this variable turretio. Now let's get this turretio and add it to the input. By this method we will accumulate the input. So when you are turning the mouse to the right, you will accumulate positive value, which will turn the turret to the right, and when you turn it to the left, it will decrease the value because the input will be negative, so it will turn to the left. Another thing we need to do is to make this replicated. Now this variable is available and visible to all clients. It is on the server and on the clients, and also this the server the custom event, it permits this. This one is very important. Sometimes if you do not replicate these variables, this one will work. So now let's go back to the event graph. Here let's call our server turretio, and let's connect this value here. Now before we go to the animation blueprint, let's make the gun pitch. So also this spring arm, we need to set relative rotation. Also break or split this rotation. Connect these nodes or execution pins. I like to connect them because when it will give us accurate and smooth control. So let's get this action value and connect it to the pitch. Now what we need is to clamp this value, because let me show you what I mean. Now let's go. Now this is our tank. For the right and left is, well, it is not moving. Let me see why. Well, I think we should lose this. Okay, still, let me see, maybe, sorry, this one, it is add relative rotation, not set. My mistake, sorry. Add, let me delete this one. Connect this to the yaw. Here, let me duplicate it. The same here. Don't forget to connect the spring arm and this value to the pitch. And let me connect this one. It is like I feel uncomfortable when I not connect them. Now let me show you what I mean. Here for the left and right it is moving fine. So if we are try to look down here, like this, and continue looking down, you see the spring arm goes very far, and this is unrealistic. You see it is now very messy. So we need to clamp the pitch. How do we clamp it? Let's get the spring arm. Sorry. It's here. Set rotation. Where is it? Set relative rotation. Where is it? This one. Now let's split this rotation. Now we need the original with the current rotation. Get relative rotation. Break it. Break the rotator. It splits it to its basic content, which is the roll and pitch and yaw. Here we need the roll, the original roll and the original yaw, but the pitch will be connected. If you need to clamp it. We need to clamp the pitch here. Clamp float and connect it here to the Y. Now let's promote these to a variable so that when we make child blueprint we can change it. Minimum min gun pitch. And this one max gun pitch. Now let me set this to -5, the minimum gun pitch, and the maximum gun pitch to 25. And let's go to the replication graph. Let's duplicate this one. Let's change this one to pitch input, and this one server set gun pitch. Pitch, and it should be run on server and reliable. Let's duplicate this one and change its name to gun pitch. So we need to get this one, the gun pitch, and add it to the input pitch input, and set the, here we need to clamp, also clamp float to make sure it does not exceed the values that we set. Also minimum gun pitch, we put it here, and this one here. Now let's go back and implement it here. Set gun pitch. Now let's connect the action value here. Let me just make it a little bit organized. Now we calculated the pitch and the yaw, and we clamped the values. Let me show you. Let's try it here. Now we look around. The gun pitch here. The yaw, I think 25 is too much, or we can go here with spring arm and maybe increase this one to 150. Now we need to transfer these values here to the gun, to the animation blueprint. So either we do casting. What is I think you know casting, but I'll explain it. Casting is getting a reference to the blueprint that you need. In this case, it is the tank. So first on begin play, let's call the begin play node here, and do cast to BP tank. Here, this cast node, what it will do, it will load this blueprint here so that we can have access to everything in it. This is very helpful and easy, but it is costly on performance. But if you have maybe 1 or 2 or maybe up to 5 or small number of casts in your game, it will not be a problem. But maybe in the future I will change it to the interface. Also, you always need a reference here. This object is a reference to the blueprint that you want to cast to. Here the reference is the owner of the blueprint, because this blueprint is present here in the enemy class of this blueprint, of the tank blueprint. So the tank blueprint is the owner of this enemy blueprint. So we can use this one, try get pawn owner, and cast to the BP tank. Now I promote it to a variable and save it here, and always do the cast on begin play so that you do not do it again and again. If you put it on the tick, it will be very costly on performance, and you do not need to put it on tick. You need to call it once and you have the access to everything in the blueprint. Here in the blueprint update animation, which is the same as the tick, we need to check is the blueprint valid, because sometimes the animation blueprint spawns before the tank blueprint, and sometimes you will get an error. Here we need to get turret yaw and get gun pitch. Promote it to a variable so that we can store it here in the animation blueprint. Now let's go to the enemy graph here, and we need to change the rotation of the turret. We use a node called modify transform modify bone. This one, it's connected here. So this bone, what we need is the rotation. So the translation and scale, we do not need them. Let's get rid of them here, like this one. Deselect, expose as pin, and here you need the bone to modify. We will choose the turret bone, break this rotation. Also for the rotation, here we need to supply the rotation mode. I will make it add to existing. I will leave component space. Here we need the gun yaw, put it here on the Z axis. Now duplicate this by using Ctrl and D. and connect it here and get this gun pitch. First of all, let's change the bone. We need the gun, this one. We just this one pitch, maybe 25. Okay, let's put the gun pitch here. Now let's test our game. Now we can move the tank. Now you see other tanks can see me move the okay. I need to change one thing, which is here in the gun. I need to change the rotation to the parent bone space. And let's try it again. Now you see it is moving. It is smooth. They can't see me. I'm moving the now let's try the others, see if they work also. Let me move. Now I can move it up and down. Now we have a fully functioning and replicating tank. I think this is enough for this video, and the next video will implement the tank shooting and firing and will make the projectile blueprint. Thank you for watching. Goodbye.